Madsen. First time I used a computer was at Iowa State University, and it was a computer built by the faculty there. And I remember the first program I wrote and ran, and I was just amazed at how fast those things could work. So I joined IBM in 1966. It was a little after these IBM 1401s, System 360 time, but see these tabulating machines here? One of my first projects was to convert a tabulating machine application to a computer application.
All right. So, first of all, what's going on in the world in the late 50s, early 60s in terms of computers? Well, they're gigantic and expensive. How many of you have been into Revolution already? Been in there? Well, if you go through Revolution, you'll see some of the early machines that were made with vacuum tubes for the switches, right? All computers and devices are filled with, today, billions of little switches, transistors, to go on and off, 1 and 0, right? Well, in the early days, we used vacuum tubes, and they were gigantic and very, very, very expensive. Really, computers were relegated to either the government buying them or leasing them, or very large companies that really had the need to do a lot of calculations and so on. And I would say that you would be paying the equivalent in today's dollars for those machines of anywhere between $80,000 and $300,000 a month. Right? Get that? Okay. You guys, maybe you're paying your self-provider, what, $100 a month? So imagine paying them $300,000. Okay, so gradually at the end of the 50s, companies that manufacture computers are starting to go to the transistor, which is developed in here Silicon Valley and other places, and that is a much faster, much more reliable device. So as we get to the end of the 50s, IBM is also thinking about going solid state, going transistorized. Now, before the existence of this particular machine, we had other ways of doing things, and I'll explain that in a minute. But you are in a very good recreation of a data center, circa 1960, one in that area. And I'd like to have your reactions to what your senses are telling you about this. Who wants to start? Give me what do you feel, hear, see?
It's noisy.
It's noisy? Right. Why is it noisy? Well, all these machines need to be cooled, and they're cooled by fans. Plus, we have a giant air conditioner back here blowing up air conditioning through the floor in a vertical direction. And we have lots of belts and pulleys and motors in these tape drives behind it. So yeah, it's noisy. What else? It's huge. It's very big because we're still doing things with relatively large devices and large circuits and so on. Big boxes. Yes, that's true. How about the floor you're standing on here? Raised up. Yeah, it's a raised floor. That's because all these big boxes need to be interconnected. And if we didn't have this raised floor, we'd be tripping over cables all over the place, like maybe you do if you try to get behind your desk at home. So that's another reason for the floor. Does anybody smell a little different in here? Like what? Metal, yes. Oil, yeah. There's a smell in here because we use lubricating oil in some of these devices because they're certainly electromechanical. Okay, so we come to the end of the 50s, and as I said, big computers are being used by the government and corporations, but in companies that want to do information processing, many have adopted IBM's punch card equipment. Steve here is going to kind of tell you a little bit about this stuff.
So pretty much, here's a punch card. This is standard IBM size punch card. It's got 10 rows and 80 columns. Each column represents a character of data. And so you start out with, here's the key punch. where the cards are punched. And then you get a stack of cards, and you can do other processing with them. Sorting, collating. There's an accounting machine that will produce reports. We don't have one right here, but there's one out in Revolution.
Just to tell you that a good example of use of this equipment might be a company with several hundred employees, and they would have, let's say, a set of cards for each employee, their social security numbers, and they can get paid, their pay rate. Every week they might fill out one of these cards, and then it's punched with how many hours they worked that week, put that together into the accounting machine, prints out a paycheck, right? And so on. So that was the way, or let's say you have to sort your inventory. You use one card for each device in the inventory. Sorry, go ahead. We do have to punch a card. Now, we want to do it with somebody's name on it, so I need a volunteer. Sorry, man. Women, only women punch cards in the 60s. Okay, come on in. Seriously, there were very few, maybe some coders who had access to their own machine. All right, we're going to have her punch her name on a card right now using the key punch, show you how it works. You only have capital letters, numbers, and a few symbols, by the way.
Okay, so these are the input cards up here. First we push the feed button to get a card down. Then we push the reg button to register it. Now we're ready to start keying. I want you, it's all uppercase. I want you to key in your first name, space, last name. All done? And we push release, reg again, and release, reg again, and here we have the card. See ya, Ellie. I'm going to hold on to this for a minute. I'll give it back to you.
Let's give her a hand. She did a great job. At the end of our demo, if there's if you guys want to punch your own cards, that's fine. So we have Cassia's card here. Fortunately, this machine also prints what you're putting in on the card. Now, by the way, if she had made a mistake, it's very hard to put the stuff back in the hole. So there's a capability on the punch of reproducing the card as far as the error and then correct the mistake. There was a guy just in here that worked in the 60s on certain projects, and he had a way of putting that chad back in the hole. All right, we're going to hold on to that for a minute.
So she punched up one card, but there were teams of people punching cards all day long, and they come up with a large batch of cards. The next step is you usually want to put them in some order. Like if it was an employee number order, so we'd sort on the employee number. So we got this deck of cards. First step is to joggle them. So they're lined up, they'll feed in the machine properly. We set this dial to the first column that we're going to sort on, and then we start the sorting process. This machine is got crutches. It's sensing the holes in the card and routing them to the correct top. And we'll finish it out. So that was the first column. Then if we had a 5-column field, we'd have to do this 5 times. For each column, once for each column. So we pull the cards out in this order. Joggle them again. Good, very good. Put them back in. Set this to the next column and run it again. But we're going to stop at this point.
So let's say we were sorting, for example, on a social security number, 9 digits, 1,000 cards a minute, you got 2,000 employees, you can just figure out in your head how long it's going to take to sort 9 digits, but it's still better than somebody sitting there doing it manually. So this equipment was extremely popular, and in the day, you could lease this equipment. Remember, IBM rarely sold you anything. They rented it or leased it to you. You could lease this equipment for your company in those dollars, about $2,500 a month, equivalent to about $25,000 a month today. But that was still better than doing things manually, okay? But towards the end of the 50s, when computers were getting solid state and advancing, IBM thought that maybe they could develop a replacement, a computer that would be more efficient than this. For example, why go through 10 passes in a sort if the computer can do it all at once, etc. You know, replace some of this card equipment, right? So what do you think the most important design criteria for that new equipment might be? Yes? Well, easy to operate, yes. What? Yes, faster, exactly. But also the price. If you're replacing somebody spending $2,500 a month in 1960, you want to be able to lease them a basic system computer for about $2,500 a month. Otherwise, why would they change? Well, maybe they're the latest and so on. But that was that target for the design. Before we do anything else, what we're going to do is take Cassia's card and show you how their computer would process her name. Now what we're going to do is run a program called Big Print. You see, we have a printer over here that only has uppercase letters, the same things that are on the card, and numbers. But in order to print Cassia's name big, we can't change the font. It's just like an old typewriter. So the program scales and says, gee, the first letter of her name is K. We're going to use little k's to make a great big K, and so on. All right? So let's do that. Here's Cassia's card. And I'm going to set up the machine to. All right. Now, if you can move down here a little bit, let's move down, and you can watch engage this noisy printer. Come on, let's move down now a little bit, everybody. All right, we're loading the program into the machine.
I think it's written the program in and now it's ready for the data.
What happened?
Okay.
You have a reader or something?
I did have a question, so maybe I ought to explain. This computer does not have an operating system. So the way we get it to do something is we load the program. And this is the program and the data. First card is a bootstrap card, which loads the rest of the program. Try it again.
So that's the application. If you like the word application, that's the program. We're going to put in the memory of the computer right now. Hopefully, this time will be successful. All right. Oh, excuse me. So here we go. see Cassidy's name really big. So later, if you guys want to do some of this, you can put your name in there. There she is. Here you go. Okay, so that's an example of running a program or an application on the 1401. Now let me introduce you to the basic system. If you just ordered the very basic system from IBM, you've got this box. This is the card reader punch. As you've seen, you can load a program. And of course, if the results you might want on cards, you could get it punched out on the other end here. For example, I don't know if you know what compiling is. You have a program in some language, you want to change it into ones and zeros in the computer, it's called the compiler. And you would output the source code on the side, machine code on the side. So, that's one box. You have this one, this is the central processing unit. Any of you got a CPU with you today? Hold it up. Yeah. Fits in your palm of your hand. Well, this one's a little bit larger. Why big? Because this was a first transistorized machine. This is about a ton, a 1 ton box. And we'll talk more about this, come back to this in a minute. And then we have the printer you saw working just now, which is capable of outputting paper at about 600 lines a minute, about 10 pages of copy a minute. And I'm sure none of you in this room remember carbon paper, but you could get about 6 carbon copies through this machine. Okay, and all these machines are interconnected, obviously, right? Well, how are they interconnected? You guys may recognize this cable. What is this? This is a USB cable. You all have these. You probably have too many of them at home because one comes with every gadget. And what does the S stand for? Serial. Good. Because each bit of a byte, it's 8 bits in a byte, is sent individually through this cable to the destination. And there's a circuit on each end to disassemble that byte, put it back together at the other end. But when this computer was built, those kind of circuits were kind of expensive. So basically, Steve's going to show you what the interconnecting cable for this machine looks like. It's a little bit bigger because all the bits are sent through the cable at once, so we have many, many, many wires. And it, believe me, it's good weightlifting exercise. So that's exactly why we have this raised floor here. Let's see, what did I do with someplace I have the puller on? Oh, there it is. So if you need to repair any of this, IBM gave you this little gadget here, and you would plunk it down on the floor like this and pull the panel. And there are the cables, the data cables, the big gray ones, and the power cables, the black ones, and they're all over the place in here. Okay?
This box here has 5 cables like that. Going to.
All right. Yeah, there's about, what, 3 per box or something like that if you connect to this cable? Okay. All right, now, how is this put together? Well, the transistor was a recent development. So this uses individual transistors as opposed to your wonderful chips that have millions or billions on one chip of transistors. These circuits were individual. So you recognize these boards kind of. These are the printed wiring boards like we use today, but the components are a heck of a lot bigger. And if you look at these boards, you can see these little cans. These little cans are individual transistors. So let your friends around you see that. And there are about 2,600 of those boards in this box behind me here, over 10,000 transistors. So you can see it was a lot kind of expensive to put together. All right, when you're done with those, please return them to us. All right, How about memory? Well, this machine, they had not invented semiconductor memory, which you have in copious amounts. And I know you think you have it, never have enough. But you have gigabytes, which is billions of bytes, 8-bit bytes. The basic machine had about 4 kilobytes of storage, and it was what's called magnetic core memory. So this is magnetic core memory. It's a bunch of vertical and horizontal wires. At the intersection of each of those is a little teeny donut of magnetic material. And the idea was you could energize them individually, either magnetize them in one direction or the other to store a 1 or a 0. Right? Expensive, but worked very well. You could pull the plug on the computer and most of your memory would still be there. So you got 4K with the basic box, and then if you wanted to upgrade, which IBM loves, there's a refrigerator-sized unit behind this here that could hold it up to another 12 kilobytes. So you get 16 kilobytes. So you imagine any coders here, write code, not much memory. You have to be pretty darn careful with them. Yeah. Okay. Well, that's magnetic core memory. All right. Now, also, we're going to show you a little bit more about this printer. Steve's going to show you a little more about the printer. We're going to, after he shows you, we're going to run another program to kind of demonstrate the kind of noise it makes and things like that. Anybody got the wiring board?
So we'll open this up so I can show you a little more about this printer and the way it operates. So you can kind of, some of you can kind of see here, there's a ribbon that goes back and forth here. Behind the ribbon,
Move on down.
there's a print frame, print chain, and it's got the characters on it. It rotates in this direction, and it's got 5 sets of the character sets, numbers, letters, special characters, and so forth. And then we have the paper that moves up in this direction. Behind the paper are hammers, and we've got a photograph where you can see them. These are hammers. There are 132 print positions, and there are 132 hammers, one for each print position. So as the desired character comes in position on the print frame, the hammer back here fires, pushes the paper against the ribbon against the printing impression. That's how it's printed. All this happens at 600 lines a minute. You got paper moving, frame rotating, ribbon moving, everything synchronized, printing at 600 lines a minute. And this had a very good quality printing output. Many printers at the time had jagged printing. It was difficult for the eyes to follow. This had printing all of a straight line. And it was one of the big selling features of the IBM 1401.
Okay. On this machine, which is called powers of 2. So we're going to tell the computer to start printing out 2, 4, 8, 16, 32 until it fills the page. So you're going to hear how this hammer system very well works. So Steve's got another deck of cards. Did you initialize, Steve?
Okay, we're loading another program in.
right. By the way, back in the day, nobody thought about wearing ear protection very much. That's why there's this noise shroud normally around this print. We'll get this out. Another one? All right, so Steve can show you here. We have printed 2 to the 328th power down here. Right? Why'd we stop there? We filled the line, right, with numbers, right. So it starts up here with 2, so on. You guys can look at that if you like. Put it over the rail here. As I said, IBM would lease you this machine for the equivalent in today's dollars for about $25,000, but almost everyone asked for some upgrade, or memory, or especially these guys here, the tape machines. Why? Because they were accumulating bazillions of cards. Can you imagine if you're a big company? One of the first companies to adopt this system was Time Life, Life Magazine and Time Magazine. They had about 40 million subscribers. Can you imagine? So when you talk about cards, Steve's got a photo here of a storage room absolutely filled with these boxes of cards.
There's a storage room of cards.
Here's a typical box of 2,000 right here. It's not exactly light. And 40 million would form a stack well up into the altitude, high altitude, might interfere with passing airplanes. So, tape is able to store tens of thousands of card data on one reel of tape. So it became a much more efficient way of storing, backing up data, etc. So we're gonna, Steve's gonna tell you how, I'm gonna start these things off. Steve can tell you how they work. Also noisy.
So you might remember when you had VCR tapes, they pretty much ran continuously. You could stop them and start them, but they pretty much ran continuously when you were watching a movie. Well, with these, it's a little bit different. Typically, read from one tape, do some processing, write to another tape, and that cycle repeats. Read, process, write. And that can mean a lot of high-speed stopping and starting of these tapes, and which could stretch the tape. So the engineers came up with these columns here to avoid that problem. So these are vacuum columns that take the tension off the tape. And there are 2 holes, you notice here at the top and the bottom. So when the tape is at the top hole, it tells the machine to feed more tape into the column. When it gets to the bottom, it tells the machine to pull tape out of the column. And then when we get to the end of the run, it would take a long time to rewind the piston, so we've got a high-speed rewind. So you notice that the tapes are pulled out of the column, read or write heads are lifted up, and it goes into a high-speed rewind. Now this one has come close to the end of the tape, so the machine sensed that, and it then returned to the slow-speed rewind to get to the end.
It's actually searching for the beginning of the first data on the tape. And IBM has a clever little thing. You put a little silver tape thing on that point of the tape. There's a little optical light sensor, so it knows where the data begins. And the machines are automatically looking now for the beginning of real data. Okay. I wanted to tell you one thing I really forgot in the beginning. Where did we get these machines? And not from IBM, it turns out. IBM long ago stopped making them, obviously. There are 2 full systems in here. We've been working with this one here. This particular system came from a family in Connecticut. They had a business doing payroll and billing for things like tennis and racket clubs and golf clubs. In fact, I have a little printout. See, this was one customer's bill here apparently in the front. Guy ate and drank like crazy. But this was being done into the 1990s, believe it or not, in this house in Connecticut. So when we got this machine, our fabulous restorers here, led by Robert, who's our videographer today, they got this machine running fairly expeditiously. However, the other machine, it came from Germany, where it had been in a warehouse rather unprotected for years and years. And when we got it over here, it needed a lot of work. First and foremost is the Europeans don't run on the same frequency of AC voltage. So we had to get a converter to go from 60 to 50 hertz power. And then we started to fix it. It took many, many years of very dedicated effort by our restoring team, many of whom, or one of whom was actually on the original design team for the system, and also other system engineers that worked for IBM back in the day. I gotta tell you, okay, lastly, how successful was IBM at leasing these systems? Well, originally, there had been estimates by marketing and engineering that they would sell 1 to 5,000 of these machines. But it turns out that by the middle of the 60s, it was the most popular computer in the world. And over its lifetime, 1,400 systems, there were other versions, there were over 14,000 systems leased. If you want to do a little math, let's say the average customer paid $6 to $8, like this is an $8,000 a month, $1,960 rental. Multiply that by 14,000 by 12. You'll get the kind of revenue that IBM was able to generate with this machine. Okay? All right. Questions? We'd be happy to answer them. Yes, sir. Oh, well, yeah, get in line. Yep. Right. Other questions? Sorry? Oh, you mean how much it cost to make them versus lease them? Well, if they were to sell them, what was the number, Robert? $500,000 in today's dollars. If you wanted to buy this equipment, how much did it cost to make? So it fit on the paper. All right. If you want to punch your name and we run it through big print, unfortunately, we have only, I think, one, maybe we have more than one operating. Still working? So some of you want to come down here, over another line. All right. Okay, first name, a space, and your last name.